Okay, let's talk about the atomic trends. Now to start off, we'll talk about the atomic radius. The atomic radius is the distance between the center of the nucleus to the outer energy shell. And the trends for the atomic radius is that it increases down a table because the energy levels increase while you're going down the table. And when it's further away from the nucleus, what happens, it results in a weaker pull, and overall it has a bigger atom. And now the reason is that if the force of attraction isn't strong between the protons and the electrons, then the outer energy levels won't be close to the nucleus. And because of that, the atom's going to remain big. When you go left to right on the periodic table, the radius decreases. And the reason is, it's because the protons increase and it results in pulling the electrons closer to the nucleus. So as you can see here, very few protons, and because of that the force of attraction between the protons and the electrons aren't that strong, so it remains a bigger atom. Whereas compared to this image, there's lots of protons, and because of that the protons attract the electrons, and so the energy levels manage to come close to the nucleus. And because of that, when you go left to right on the table, the right side has the smallest radius. Okay, let's talk about electron affinity. Electron affinity is the ability to attract electrons. High negative numbers is equal to high electron affinity. And what I mean by negative numbers is when you move to the right side of the periodic table, the tendency to gain electrons increases. And for example, fluorine, it has a -1 on the periodic table, and what that means is that it just needs one more electron in order to have a full octet, or also known as a valence shell. And because of that, it has a high electron affinity. And the reason is, instead of giving away its electrons to have a full shell, it rather gain one because it's easier. And when you have a low negative number, it's low electron affinity, as well as with the low positive numbers as well. When you go from left to right on the periodic table, the electrons are needed, they are wanted. When you go from bottom to top, it increases. And the reason is because it results in fewer shells. It has a stronger pull on electrons as well. So when you look again on the halogen group, for example fluorine, it has few shells, and the pull on the electrons are very strong. So it's really hard to take out. So the easiest option is just to gain an electron. When we talk about ionization energy, we're talking about the energy required to remove an electron. And ionization energy is the complete opposite of electron affinity. When you go from bottom to top, left to right, the ionization energy increases. And the reason is it's closer to the nucleus and the attraction is stronger. As I mentioned before, fluorine, the energy levels are very close to the nucleus, and because of that the attraction is so strong that it's almost impossible to remove an electron from there. So what it does, it just gains one. Now a good example of ionization energy would be something like lithium, sodium, and potassium. And the reason is because the force of attraction is so weak, and all it needs to do is just give away its electrons in order to have a full octet, and they don't really mind that because it's easier for them to give away rather than gaining electrons.